Okay, so this worksheet will have a lot to do with the cubic formulas, the difference and the sum. So just as a reminder, I'll put them here. So your difference of cubes formula and the sum of cubes formula. So we'll use them almost in every question right now. So the first problem, 2x squared plus 1 over x cubed minus 1 minus x over x squared plus x plus 1. In order to find the least common denominator, the first thing we always have to do is to factor. Right? That's the first step every time. So when you look at that first denominator, we should realize that that's a difference of 2 cubes. So we'll use the difference of cubes formula, right? So x plays the role of A, 1 plays the role of B. So the first denominator breaks down into x minus 1 and x squared plus x plus 1 minus, can I factor the second denominator? How? No. X plus 1, x minus 1 is x squared minus 1. Even if I can't factor the second denominator, is that a big problem for this, in this case? Why not? Yeah, because that entire second denominator is a factor of the first denominator. And I cannot factor that even if I try, but it's not a big deal because I see this guy is the LCD. LCD is x minus 1, x squared plus x plus 1. So that means we're only missing x minus 1 on the second fraction. Is that right? So this is all we have to do. Multiply by x minus 1 over x minus 1. So this way we have 2x squared plus 1 over x minus 1, x plus 1, and then minus x times x minus 1. Now if you pull everything together, it comes out like that. Not yet. I would love to. Are we okay how we got to this point? For those of you who were here at the beginning of the problem, mostly? Is that all right? So from this point on, whatever that LCD is, my job is to open up the parentheses, combine like terms. So when I do that, 2x squared minus x squared is x squared plus x plus 1, and then denominator is x minus 1, x squared plus x plus 1. So what can I do with that? Can I simplify it further? Can I simplify this further? This final step here? No? Why not? Just now? Yeah? What? Make a decision. Why not? Is it done? So I can simplify it? How? Can I factor the top? How? No. If it had a 2 in the middle, then yes, it doesn't have a 2. But again, is that a big deal that I cannot factor the top? What is so special about the top right now? Yeah, so this thing is identical to that thing. So I can divide by that entire factor. That entire factor cancels. 1 over x minus 1. I still have 1 in the numerator. So the final answer is 1 over x minus 1. I can always cross out the same factors. So since x squared plus x plus 1 is a factor of the denominator, and that's a factor of the numerator, I can kill that entire term. How's that? Is that good? Well, the next one, if that's not so good, the next one might make it a little better. It's a very similar thing. Since you all have this piece of paper, I'm just going to start factoring as I'm writing. Is that okay? I won't be writing the original question because you have it. Right? That's what we're doing. So the first fraction is just 1 over b minus 3, while the second fraction, we should recognize that as a difference of cubes. Do we recognize b cubed minus 27 as a difference of 2 cubes? Because 27 is a perfect cube, 27 is 3 cubed, so b is 3 right now. So I can break it down, that's not right, into that. So using the difference of cubes formula, b cubed minus 27 becomes b minus 3 times all that wonderful stuff. So what is the LCD? B minus 3? Is that it? What is the LCD? Yeah, so I need both of those, right? We need all distinct factors pulled together. So that tells me that the second fraction is all set. The first one is missing that trinomial. So I just have to multiply the first fraction by the missing trinomial. Now the second one stays the same, don't change that. So same denominator. So that means I can pull everything together. I'm just going to write LCD down there. And in the numerator, we have b squared plus 3b plus 9 minus 9b. How is that? What, 9b? Is that what? Are you? Okay. Yeah, because, right, that's what I want to achieve. Same denominator. So, combine like terms, we'll end up with b squared minus 6b plus 9 over, well, let's write that denominator down. Are we done, or can I do something else? Factor the top. How would you factor the top? Right, so b minus 3 squared. That's a perfect square trinomial over b minus 3 times b squared plus 3b plus 9, so I can reduce by a factor of b minus 3. So we can cross that and one of those. So we still have a factor of b minus 3 left in the numerator, all over b squared plus 3b plus 9. And that's as far as I can go. Questions on that? Can you reduce that any further? So we're good? We're happy with that? So again, the process stays the same. First step is to factor, find the LCD by pulling all different factors to the highest power that you see, multiply by what's missing, and then mess with that numerator. See, I'm not even writing the denominator. It doesn't matter till the very last step. So simplify the numerator, factor the numerator, and hopefully reduce, and then you're done. Yeah? These are our steps. I'm going to skip the third one for now. You're not ready for that. Let me do the fourth one, and then we'll come back and do the third one. So, I have a fraction, and then I wrote it wrong, didn't I? Yes. That is a plus, and that's the minus. So we have a fraction, and then I'm adding, subtracting things that are not fractions. How do we do that when you add, subtract fractions with non-fractions? Huh? Now put what over 1? The whole thing, not right? Not x over 1 and y over 1, the whole thing. So really what you're doing, you're treating x minus y as a single item. So when you put it over 1, you're really putting parentheses around it. You're treating it as a single item. Does that make sense? You can put x over 1 minus y over 1, but why bother if you can put the whole thing over 1? So you're really putting a set of parentheses. Okay, good. So one has that big, ugly denominator. The other one has a denominator of just 1. So it should be pretty clear what the LCD is, right? What is the LCD? What? Did you say something like that at the end? Don't say something like that. Give me... No, I cannot factor the bottom denominator. Even if you try, that doesn't factor, right? Yeah, so whatever that bottom denominator is, that's your LCD. You were trying to say that although you were trying to factor it, it's not factorable even if you try hard. But yeah, whatever that thing is, that is the LCD. So the first one is happy. I just have to multiply the second one by that LCD. Right, that's the idea. So this way they have the same denominator. So when I pull this together, it's going to be x cubed plus y cubed plus x minus y times x squared plus xy plus y squared all over whatever the denominator was. Well, that's the idea, right? They have the same denominator now. So I can put them together by adding the numerators. Denominator stays the same. Denominator doesn't change when it's same denominator. So now I have to simplify the numerator. How would we go about that? How can we simplify that numerator? What would you do? Don't do it yet. Tell me your plan. Why? With the denominator? No. Remember, we can only cancel if a factor, I mean, whatever you're trying to cancel is a factor of the numerator. It's not a factor of the numerator yet. If you have this parenthesis like this, if all of that was grouped together, then this is a factor of the numerator. It's not right now, because in the numerator you have a combination of pluses, minuses, and products. You don't want that. You want your numerator to be factors. So in order for that to happen, you first have to open up all the parentheses, combine like terms, and then try to factor. So the plan is to multiply these two. So the question is, does the product of these two parentheses look at all familiar? Can we multiply it fast? Yeah? What does it look like? What do these two parentheses remind you of? Yeah, the difference of cubes. So I don't have to work really hard. I know the product of these two parentheses is just going to be x cubed minus y cubed. I don't have to FOIL. If I FOIL, I'll get the same answer. But based on your exam, you're really better off using the formulas than FOILing, because you mess those up. But formulas of quick multiplication allow you to open that without FOILing. So the y's cancel, and you end up with 2x cubed over x squared plus xy plus y squared. I didn't get x squared minus y squared. No, I didn't. Yeah. Yeah. Yeah, I didn't get x squared minus y squared. Well, first of all, let's agree on what did I get there? But no, you said x squared minus y squared. Yes, thank you. So that makes a difference, because I didn't get the squares, because this thing is identical to that thing. So therefore is that. Or you just FOIL. I mean, if that doesn't make sense, FOIL. I mean, that's the plan. It's just going to take a few extra minutes. You'll have to perform 6 operations, which means you're probably going to make an error somewhere at one of them. So if you recognize a formula, it makes it a lot quicker, and you're less likely to make an error. You just use the formula. Okay. Now that was D. Let's go back to C. So what happened? What? Yeah, so because I also got a negative y cubed out of the green box. So they canceled. I only left with x cubed and x cubed. So that's 2x cubed. Is that okay? So these two questions very similar. I have a fraction, and then I'm subtracting a whole bunch of things that are not fractions. How did we treat that in the previous example? Put it over 1. Right, parentheses. So that's the whole idea. If I put it over 1, That means I'm treating all these three terms as a single entity, right? So if I put parentheses around that, I also have to change those signs because of the negative. Because really what I did, I factored out the negative, so everything inside became positive. If I don't do that, I just changed the problem, and I shouldn't be doing that. So really, by putting the parentheses, we factor out the negative. Because we didn't have a negative in the previous example, so that didn't matter. There was a plus, so nothing changed. But here, because of the minus, when you put a parenthesis, you're really factoring that negative out. So yeah, that's still over 1. So the LCD then is pretty clear, right? It's just m minus n. So I just have to multiply the second one by m minus n over m minus n. Right? Okay. So see if I can cram it all in here. M minus n in the denominator. So the first numerator is this minus m minus n times m squared plus mn plus n squared. So again, notice how all those minuses became pluses because we still have that one big minus up front. And again, can we multiply m minus n and m squared plus mn plus n squared fast? Difference of cubes, so that becomes m cubed minus n cubed. And again, it matches our formula perfectly. So m cubed plus n cubed minus m squared, m cubed minus n cubed. So I'm going to keep it in the parentheses for now, and then we'll distribute the negative. Right? Again, I have to be very careful with the order of operation. Multiply first, then subtract, so whatever the product was still remains inside the parentheses. Because that negative, basically that little minus sign made this problem a whole lot harder than the one we just did. It's really hard to keep track of all the negatives. So again, just keep in mind your order of operation. Multiply before you subtract. So then m's cancel, you have 2n cubed over m minus n. Right, m cubed. What? Oh, it does matter. Whatever has opposite signs, that's the one you cancel. Questions on this? Did all those sign manipulations make sense? Yeah. Uh-huh. Oh, here it is. There's the first step.
Oh, okay. I was saying multiplied by n minus n. Like how do you get that to like you're gonna multiply by?
You mean this one? Oh, okay, because, well, I'm looking at two denominators. One has m minus n, and the other one just has 1. Right? So the question is, well, how can I make them the same? The only way you can make these two denominators the same if you multiply the second one by m minus n, whatever is missing.
So it's always the
Well, it's not that. I mean, if one of the denominators is 1, then you just multiply by whatever the second denominator is. Okay, again, every time you have to find the LCD, in this case, the LCD is m minus n, because that's all you see. Right? That's the least common denominator. Well, sure, if that makes sense. But in general, again, if you find the LCD, then you compare your LCD with each denominator. M minus n, m minus n. All right, we already have that. M minus n and 1. How do you turn 1 into m minus n? Well, you multiply it by m minus n. Same thing we did here. We had two denominators, 1 and whatever. We decided LCD is, well, whatever that was. Right? So the first one is happy. We didn't touch the first one, but the second one had to be multiplied by whatever expression necessary to make it equal the least common denominator. So it happened to be the entire least common denominator because there was just 1 at the beginning. Right? if I go back a page, this one, here's the least common denominator, right? So you compare that with the first denominator. Here's the original first denominator, so they are identical. Nothing needs to be changed, right? Your first fraction here has the same denominator as the LCD. Now when you look at the second fraction, does the second fraction have the same denominator as the LCD? So you multiply by whatever's missing, right? You compare this with the LCD, you see that it's missing the x minus 1, so multiply by x minus 1. So that same concept just carries on. You find the LCD, and then you multiply by the terms that are missing when you compare your original denominator with the LCD. Same thing here in this example. When we factored, we realized this is the LCD, and then you compare the LCD with the first denominator. Okay, b minus 3 is there, but I also need b squared 3b plus 9. So this is us multiplying the first fraction by the missing factor. While the second fraction has the entire LCD in there, so we're good. Okay? So when we had those examples with over 1, it's really the same idea. You just compare the LCD with the denominators, and then you just multiply by whatever's missing. So with 1, it's just the whole other denominator. That's what's missing. Right? I mean, if we did this problem, 1/2 minus 4, how would we go about that? We would put 4 over 1, 2 over 2, right, to get the same denominator. So it becomes 1/2 minus 8/2. So that's the same idea. So whatever that is, negative 7/2, right? Same concept. You find the LCD, you multiply by what's missing, and then you treat it as a problem with same denominators. Does that make sense? All right, well, let's do the next one. Next one is slightly different. So E. So, okay, 9x squared. I'm just going to copy it over. Even if I try to factor, nothing really factors in this problem. So I'm going to leave a little gap here so I can multiply. What is the LCD? Right, I need both of them. Remember that these two denominators are so different. I cannot do any of those little tricks to make them equal. The tricks that we were doing on Wednesday change both signs. Remember, if one denominator was like this and the other one was like that, then we can tweak them to make them the same. So that means you change both signs. Here, they only differ by one sign. 3x has the same sign, y's have opposite signs. So when you see that, you cannot make them the same. They're different. So we need both of these. Basically, that's the message. So the LCD is 3x minus y and 3x plus y. So compare your original denominator with the least common denominator and tell me what is the first fraction missing. What? 3x plus y, that's right. So you compare the original with the LCD, so 3x plus y over 3x plus y, and the other one, 3x minus y over 3x minus y. So that means when I pull everything together, let me write it like this. 3x plus y times 9x squared minus 3xy plus y squared plus 3x minus y, 9x squared plus 3xy plus y squared. All over whatever the LCD is. I don't care. There are two reasons why I'm just writing the LCD as 3 letters LCD. First reason, because I'm lazy. I don't want to write it because it's not important at this point. And two, by not writing it, I don't have this urge to start canceling things before it is legal. Because right now, it's not legal to cancel anything because of the big plus in the middle. That prevents us from reducing anything. I don't know how many of you heard me say that, but yeah, that's the idea. So, yeah. What? I'm not sure. Oh, yeah. That's just me being silly. Yeah, you're right. Yeah, this is just me writing it faster than I should. The y is squared, not the parenthesis. Yeah, good. Otherwise, it makes a huge difference. I mean, that made it completely insane. Okay, so the plan is to simplify the numerator. That means I need to open up all the parentheses, combine like terms, and then kind of see what I can factor and reduce. So the question is, look at the first product, 3x plus y, and then that other thing. You're kind of looking in the right direction. Does that kind of seem to be in the same format as the cubic formulas? You have a 3x. If you square 3x, that's 9x squared. If you multiply them, that's 3xy. And if you square y, it's y squared. So it follows the sum of cubes formula precisely, right? What is a? 3x, right? So the formula tells me cube a, so 3x cubed becomes 27x cubed, and the y cubed is y cubed. The product of these two parentheses, just using the sum of cubes formula, becomes this. No, because I got to cube the a, so I'm cubing the 3, right? Well, yeah, this is what's happening. It's really 3x quantity cubed plus y cubed. So you're cubing both. It becomes 27x cubed plus y cubed. So the other two parentheses is the same thing, only with a minus. That's a difference of cubes, so 27x cubed minus y cubed over whatever the LCD was. The y's cancel. 27 plus 27 is 54x cubed all over 3x minus y, 3x plus y. And nothing much I can do about that. If you did not recognize the cubic formulas, that's not a big deal at all. You can FOIL. You'll get a large expression. You get 6 terms out of the first FOIL. You get 6 terms out of the second FOIL. That's how many terms? 12 terms. And 10 of them will cancel. So you have to be very careful when you FOIL. But if you operate with these formulas, it's a little faster. But again, if you FOIL, you get the same result if you FOIL properly. You with me on that? Yes, no? Okay. Let's do the next one. So it is 1 over b plus 2 minus b over b squared minus 2b plus 4 minus 12 over, well, b cubed plus 8, the third denominator. Is that something special that I can factor? What was that? But what does it look like, the b cubed plus 8? You have it in your paper. Yeah, that's why there's... I'm talking about that thing in front of you. Yeah, so it's sum of cubes. Recognize that. And the sum of cubes is precisely the product of these two factors. That's what b cubed plus 8 is. If you factor b cubed plus 8, it becomes b plus 2, and then b squared minus 2b plus 4. Right? Because a lot of times we throw that at you. We kind of mix those factors together, so even if you have hard time factoring that, in order for this problem to be somewhat friendly, it probably should factor into the other two. But again, I just used the formula for the sum of cubes to split that up. So then we see that, what is the least common denominator here? So that thing, right? b plus 2 times b squared minus 2b plus 4. I just need all different factors raised to the highest power. So that tells me that the first fraction is missing the trinomial, right? Is that okay? So the first fraction, 1 over b plus 2, gets multiplied by b squared minus 2b plus 4 over b squared minus 2b plus 4. What about the second fraction? Well, multiply by b plus 2. Multiply by what's missing when you compare it with the LCD. Well, the third fraction is happy. Is that okay? So when I put everything together, we'll get the following. From the first one, is b squared minus 2b plus 4 minus b times b plus 2 minus 12 all over whatever the LCD was. So the numerator, you just pile them all together, because now they all have same denominators. So I need to open up the parentheses, combine like terms, and see what that gives me. I can right away go 4 minus 12 is negative 8. I can do that already. Can I? Will you hold that against me if I kind of do that right away? 4 with a negative 12 is negative 8. So that I have b squared minus 2b minus 8 minus b squared minus 2b all over the LCD. So b squares cancel. Negative 2b minus another 2b is negative 4b minus 8 all over, well, let me write the LCD now. Can I do anything else? No? Well, when I ask you, can I do anything else, at this stage, you have to think, well, can I factor? That's really what I'm asking. Can you factor something? Yes. What can I factor? Sure. That b plus 2 shows up, and then cancels with the b plus 2 in the denominator. You really have to look after that, because then b plus 2 is canceled, and that's negative 4 over b squared minus 2b plus 4. And that's it. So always look for the ways to factor. Because on my math lab, if you get to this point and you put that as an answer, it will be marked wrong, because it's not the answer. You have to reduce it. So make sure you get it down to the lowest terms possible while keep things legal. So I shouldn't be canceling the 4's, right? Over here, because of the big pluses. So that's it. That's as far as I can go. Questions? Again, we're just doing the same steps. First step is to factor. By factoring, you can find the least common denominator. When you found the least common denominator, you're going to multiply by whatever each fraction is missing. That's the big step. You compare the original denominators with the LCD. After that, you pull it all into the same fraction, simplify the numerator, factor, and reduce. Same steps, over and over and over again. Okay. So the next one. Again, I'm going to write it while factoring. Well, 1 over b minus 5 squared. B minus 5 squared is already factored. That's factored. How about the middle one? Can I factor the middle one? That's right, b minus 5, b plus 5. And the last one is factored. So, when you look at these three fractions, when they're already factored, what is the least common denominator here? Squared, that's right. Right, because the last one is squared. So you always take the distinct factors to the highest power. We see b minus 5 and we see b minus 5 squared. We'll take the highest power into the denominator. Same thing with b plus 5. So you have b plus 5 and b plus 5 squared. We always take the highest powers. Is that okay? That's what we agreed on. That's how we find the common denominator for numerical example. If there is a prime factor that repeats more than once, we always choose the highest power. So look at that first expression. What is it missing? What is the first denominator missing in comparison with the LCD? B plus 5 squared. You compare the original with the LCD. We're missing b plus 5 squared over b plus 5 squared. Minus 2 times b minus 5 b plus 5. What are we missing there? Yes, one of each, right? So b minus 5, b plus 5. So I have to multiply by b minus 5, b plus 5 over b minus 5, b plus 5. And finally, the last one is missing b minus 5. Ugh. A lot of writing. Is that good? Found the LCD, multiply by what's missing. So now everything has the same denominator. So we can pull it all together, whatever the LCD is. So it is b plus 5 squared minus 2 times b minus 5, b plus 5, plus b minus 5 squared. What should I do now? Get rid of the parentheses. So just do all those wonderful operations that get rid of the parentheses, right? What is b plus 5 squared? How do you square b plus 5? Anyone? See, I forgot to put that on your test. How do you square a sum? Don't you have a very special way of squaring a sum? What is the formula for squaring a sum? Plus 10b plus 25. It's your a squared plus 2ab plus b squared formula, the one that you know. We only had that to factor on your test. We didn't have to square. So that's that. What about the middle? O is b squared minus 25. That's the difference of squares. And the last one, b squared minus 10b plus 25. Is that okay? Using your square of a sum, square of a difference, and difference of squares formulas. Yes. Is that okay? I can cross out 10b's probably right away. B squared plus b squared is 2b squared. Is that okay? 25 plus 25 is 50. And then minus 2b squared plus 50 over the LCD. The squares cancel. 2b squared minus 2b squared. 50 plus 50 is 100. Over the LCD. And nothing else I can do. Questions here? Again, we factored, found the LCD, multiplied by what's missing, simplified the numerator, combined like terms. We got the answer that cannot be reduced any further. Is that okay? Now, there's something interesting about this problem. Look at that numerator, this stage right here. Look at the pattern in that numerator. Do you see the pattern? You have something squared in the front, and then you have something squared in the back. And in the middle, you have those two things multiplied, not squared, with the 2 in front. Right? It does look like a squared minus 2ab plus b squared formula, doesn't it? It has the same pattern. What is playing the role of a over there? B plus 5. What is playing the role of b? B minus 5. We know that this thing factors into a minus b squared. Right? That's the formula. So that means this numerator can be treated as b plus 5 minus, well, the quantity, b minus 5 squared. This is our a minus b. Right? Same thing. Now, if I simplify this, that's b plus 5 minus b plus 5 squared. B is canceled. 5 plus 5 is 10. 10 squared is 100, just like we got in the end. Isn't that cute? But again, you don't have to notice that. This is a hard thing to notice. If you notice it, that's a little quicker. If you don't notice, that still works. Opening up all the parentheses, combining like terms, still gives us the right answer. It's a little longer, but there's another way of doing that. Eric? Did that make sense? That's okay. Again, as long as the first one made sense, that's all that matters. If the second one made some sense, then it's good. Some of you probably got the second part. All right. So the last question, verify. That means somehow the left-hand side is really the same thing as the right-hand side. And the way we verify the identities is you mess with one side until it looks like the other side. So which side should we mess with here? Left or right? Left. And really, this is just like any other questions. I'm just giving you the answer. Whatever's on the left should be 1 over 5z. So our job is to get there. So I'm gonna start writing the left-hand side, and I'm gonna factor it as I go. So what can I factor out of that first denominator? A z. So pull out a z, and leaves you with 2z plus 5. And this is totally by design that this problem has a lot of 2's, z's, and 5's in it. That's done on purpose. So pay attention to your penmanship. 2's, z's, and 5's will drive you crazy in this problem. How about the second one? Can I factor something in the second one? 5 leaves us with what? 5 minus 2z. And the last one is difference of squares. 2z minus 5, 2z plus 5. Okay. I have a lot of 2z plus 5's, 2z followed by 5. Only one of them is 5 minus 2z, the middle one. Should I do something about the middle one to make this problem a little manageable? Yeah, I can flip this one around the minus. It will change that to a plus. Remember that. If you flip around the minus sign, it changes the sign of the whole expression. So that saves us on the LCD just a little bit. Let me copy it over, show you what we have now. It's 1 over z times 2z plus 5. I'm going to leave a little gap. So I'm going to be multiplying by the missing parts. Now it's plus 2 over 5 times 2z minus 5. And then I'm going to leave a little gap again. And then it's minus 4 over 2z minus 5, 2z plus 5. Okay. What is the LCD here? 2z minus 5, 2z plus 5. What else? What else do I need in there? I need a z and I need a 5. I need all the factors pulled together. So I need a 5, I need a z, I need a 2z minus 5, and I need 2z plus 5. So I need all distinct factors raised to the highest powers. So compare each denominator with the LCD. What is the first denominator missing when you compare it with the LCD? 2z minus 5, and what else? Missing a 5 as well, right? 5 is a part of the least common denominator. So I need 5 times 2z minus 5 over 5 times 2z minus 5. Even though 5 appears in 2z plus 5, does not mean that 5 is a factor of 2z plus 5. So we need 5 as a separate entity in there. The second one is missing z, and then 2z plus 5 over z, 2z plus 5. And the last one is missing 5z over 5z. Well, that's what it is. 5 times z is 5z. We don't say 5 times, but yeah, that's what it is. Okay. So we got our LCD. So now we just have to pull everything together. In the first one, we have 5 times 2z minus 5, and then plus 2z plus 5. And the last one is 4 times 5z, so it's negative 20z. Is that okay? 5 times 4? Uh-huh. What? Yeah, so it's 2z that, so that's the numerator. the denominator is just always going to come out to be the same. That's the idea. So now I have to open up all the parentheses, combine like terms in the numerator, keeping the denominator the same. Denominator won't matter until the very end. So distribute 5 gives you 10z minus 25. Distribute 2z gives you 4z squared plus 10z. And then we have minus 20z. So we have 10z plus 10z minus 20z in the numerator. What's going to happen with all of that? Yeah, 10 plus 10 is 20, minus 20 cancels. And then what we'll have left is 4z squared minus 25 over, let me write the denominator now, 5z, 2z minus 5, 2z plus 5. Right, that's my denominator. Can I reduce that? Yeah, the 2z minus 5, 2z plus 5 is the same as 4z squared minus 25, right? Yeah.
Use about 10z of those are positive.
Yeah, but then it's minus 20. So it's 10, 10, minus 20. So yeah. So I had 3 terms. So yeah, since 2z minus 5, 2z plus 5 results in 4z squared minus 25, I can just basically cancel both of them with the numerator. And what we have left is 1 over 5z as requested in the problem. Right, that's what we wanted. So that means we're done. Good? Questions on this? Same process. Factor, tweak if necessary. We had to tweak a little bit. Find the LCD, multiply by what's missing, simplify the numerator, and reduce if possible. Does that make sense? All right, good. That's our little worksheet.